Okay, good morning. I hope everybody's doing okay today. We're going to go ahead and get started, if that's okay. I would like to start by taking any questions that you may have, um, because we still have a couple of students that are not here. So I want to give those folks, I want to give those people another minute or so. But while we're waiting for them, Uh, if you have any questions, by all means, please feel free to ask. Okay, looks like we might have a couple of questions. Solomon, we're going to talk about that in just a moment. Uh, we're going to start our exam at 9 a.m. instead of 8 a.m. because you guys don't get any longer than any other Tech Math 204 student taking the midterm exam. There's no point in us being there at 8 a.m. And I think it gives everybody a little bit more flexibility with time. So we're going to start the exam at 9 a.m. You get the same amount of time as everybody else. You get from 9 a.m. until whenever class ends. I think it's 10:40 a.m. So officially, the exam students are allowed 90 minutes, which is an hour and a half. So I'm going to let you start at 9 a.m. and finish at 10:40, which is, I think, when we finish. Yeah. But I am going to talk about that in a little more detail in a minute. Yes, Brian, we'll go over quiz 5. Why don't we do that right now? Question 5 on quiz. I guess you're referring to the quiz that you just took. Um, okay. Okay, I don't really understand your question because uh, there is no quiz 5. So you're going to have to be a little more specific on what you're talking about. I don't know where you're at. So quiz 1, question 5. Oh, on the quiz. Gotcha. I misread. Okay, quiz 1, question 5. Let's. First of all, I want to confirm that this is the question you're referring to. Well, it won't be exactly the same. It won't be exactly the same, but it should be uh, similar to your question. So does this look kind of like your question? Okay, yeah. Okay, so we'll go over that. That'll be a good way to delay a little bit while students are still trying to arrive. So this is a very important question. So everyone should be thankful to Brian for asking this question. It is highly likely you're going to see something like this on your midterm exam and maybe on your final exam. It is an important type of problem to be able to do, having gone through this course and going on to your application courses. One thing I will warn you about is that on the exam, we oftentimes require students to actually draw their triangle. So you might actually be given sides and angles, and you may have to draw the triangle yourself. Note here that this problem says that the picture is not drawn to scale, but be very careful to assume what it's basically saying is a little bit confusing in its writing. Basically, you do not want to assume that any angle is acute or obtuse. You don't want to make too many assumptions about this picture here. It's just meant to kind of guide you. Now, I do want to say this. In ideas, anytime a picture of a triangle is given, and you can assume this on an exam or quiz too, is that it might not be to scale, but the angles and the side lengths are roughly in the right orientation. Things are roughly correct, okay? So you can assume things are roughly correct. And what we'll do is we will take a look at this, and we'll take a look at the answers that we get, and we'll see if they're roughly matching the picture we have here, and then move from there. Okay, now, so it says here, given the triangle below, find the angle A and the length of side X. So I'm going to start with the fact that this is a probably not a right triangle. I mean, the picture shows a non-right triangle. It's probably not a right triangle. You should not assume it is a right triangle. So we have to use law of sine or law of cosine. So that goes back to stuff that you would have seen in previous weeks. Now, I want to bear with me for just a moment. I'm going to stop sharing for just an instant, just a moment here. Because I want to pull up your formula sheet. Okay. By the way, I did attach your formula sheet in the midterm exam folder on ideas, so you can go in and take a look at it if you want. So this is your midterm exam formula sheet, and at near the top of this document are the law of sine, law of cosine. So I'm going to drop this somewhere. Let's put it over here, I suppose. Okay, so here's law of sine, law of cosine. All right, and of course you'll need you'll get that on your that's from your formula sheet. So what you want to do is you want to consider what you're given and what you are looking for. Now, very important aspect of this problem is to remember that when you're using law of sine, law of cosine, and in general, when you're drawing any triangle like this, or really any triangle, you should be using that scheme that we talked about a couple of weeks ago. So it's been a couple of weeks. And that scheme is that when you draw a side, like side A, it should be opposite of angle A. When you write label side B, it should be opposite of angle B. Usually you use lowercase a for the side and uppercase A for the angle. Very important. Very important. So when I label this, I should label 26 as side A because it is opposite of angle A. Angle C. We'll call it, sorry, side B. It doesn't, we don't have 39 degrees labeled down there, but I'm going to call the side B over there for 20, and then this will therefore be side B. Sorry, angle B. And I'm going to replace side X with side C, just so I can draw my picture. And then that means this angle up here will be angle C. So this is very important. I can't understate this. Very important. You need to know to draw your angles like this and in this sort of configuration, angles and your sides. Okay, so now that we have the picture label to get us ready for law of sine, law of cosine, I want to point out that what we are given here is a form of side-side angle. Note that it is not side angle side because we would need to be given two sides, and those two sides need to be adjacent to each other, and you would have to also be given the angle between them. So this is not, because we don't know C here. You know, we're looking for C. So we don't know that side. So this is not a side angle side configuration. This is a side angle configuration, which we need law of sine for. Okay, so law of sine basically applies to everything except for side. Sorry, I get it backwards. It applies to everything except for side angle side and side, right? Those are the configurations that apply to the law of cosine. So we talked about all this 2 weeks ago. Okay, so if you missed 2 weeks ago, you maybe need to go back and watch the recording. The recording is in ideas. And of course, everything else we use law of sines. All right, so since this is an everything else situation, we're going to use law of sines. So let's write it down. Okay, now what we first need to do is figure out what we are given. And in particular, for law of sines, you have to be given at least one side and its opposite angle. So in other words, I need to be given either A and capital A, or B and capital B, or C and capital C. I got to be given one of those pairs in order for law of sine to be helpful. Okay, so let's see if we are given any side and its opposite angle. All right, so if I'm not mistaken, we're given side B and angle B. So we are given at least one side and its associated opposite angle. All right, so let's plug those in or substitute them in. So it goes in the middle here. Okay, and then I need to look at what remains. What else am I given that remains? Well, I'm given side A, so I'm going to substitute in side A. 26. And then I'm going to substitute in, or not substitute, but I'm just going to write the denominator down for that. Now, considering what I'm given, I now have the equation that I need to solve this portion of the problem. I do not need the C over sine C stuff because I am not given anything about side C or angle C. So I'm going to use this equation here to find angle A. So I'm going to use it to find angle A, and that will be my first part. Now, in order to use this, you have a proportion here, so you can just cross multiply. But at the same time, we have to isolate A, which means we have to isolate sine of A. So I'm going to divide both sides by 20 now. And of course, I'm looking for the angle A, and you guys should be comfortable with using inverse sine to find the angle now. Okay, so I'm just going to take all this, substitute it right inside that bracket. So when I type this out to get my answer, alleged answer, I've got to type inverse sine of, okay, my numerator needs to come first. So 26 times sine of 39 degrees. Go down to my denominator, divide by 20, and close my bracket. Okay, now this is going to give me some kind of a solution. Okay, 54.90 degrees. It says to round to 2 decimal places. Okay, now I want to look at this, and it would be very tempting to write this down. In fact, if you worked this problem, but you got it wrong, I highly expect you probably got this answer, and this answer is probably what ideas is counting wrong, right? The reason why it's wrong is it does not make sense in terms of the picture, even remotely. As I said, the picture is not drawn to scale. However, it is in the roughly correct orientation. So if I look at this angle, 54, 55 degrees for A, I can see that this angle A right here does not look anywhere remotely like 54 degrees. It looks like an obtuse angle, so it should be at least 90 degrees. So we're missing something here, right? We're missing something. And so this cannot be the correct answer. So the answer to our concern here is remember we were talking about other solutions to trigonometric equations last time. And so the answer is you have to find the other solution where sine is, in this case, positive. Because if you calculate all of this inside here, you'll figure out that it's, in fact, positive. You get positive 0.818. So we have to use our cast system from last class and or I like to call it add sugar to coffee to find the correct angle. So let's do that now. Okay, so this is what we were doing last class in the second half of the class. So what we do to use our cast system is we draw the angle that it gave us, 54.9 degrees. So that's going to look something like that. Okay. And then we ask ourselves, in which quadrant, other than the first quadrant, is sine positive? So that number over there is a positive number. We just checked it. It's 0.818. So 0.8, what was it? 0.8181. Okay. So you can see that's a positive number. Sine is positive. So where else is sine positive? Well, remember last week, cast or add sugar to coffee tells me exactly where the trig functions are positive. A means all, S means sine is positive, T means tangent is positive, and C means cosine is positive. Okay. It also tells you where the trig functions are negative. A means all are positive, but that means none of them are negative in this first quadrant. So this is called the first quadrant. S means sine is positive, so that means the other two functions, cosine and tangent, are negative. In the third quadrant, tangent is positive, which means sine and cosine are both negative down here. And finally, quadrant 4, C means sine is positive, so that means both sine and tangent are negative down here. So here we're interested in where sine is positive. So where else is sine positive? Well, it's over here in this quadrant. So what we do is we have to draw a reference angle, with respect to the x-axis into that quadrant that is a mirror image of 54.9. To find the obtuse angle, you have to figure out what this is as an angle in standard position. And you guys should know that that is 180 minus 54.9. So that will be the correct angle. Remember, the straight angle, if I go all the way around, is 180 degrees. And I know that this little corner right here is 54.9 degrees. So if I just subtract that off, I've got my correct angle. So I should take 180 minus 54.9. So the correct angle here is 125.1 degrees. Sorry, 125.1 degrees. So this is something you have to watch out for, and this is why this is such an important example. You should not assume you sort of need to do a good reality check on your solution. This is only an issue for the angle. You got to do a reality check on your angles, because if the angle you get does not match the picture, then it doesn't make sense. You have to look for the other angle. And so that's the purpose of what we've been talking about. You also talked about how to find the other angle. You should have talked about it in Tech Math 104. Okay, now the only thing left to do here is to find side C. Now, I want to be clear. Sometimes students try to use the Pythagorean theorem to find side C. You cannot do that. The Pythagorean theorem only applies to right triangles. Okay, so you can't use the Pythagorean theorem on this. The only option here is to use either law of sine or law of cosine. Now, I probably should use law of sine because it's easier. However, since we're doing this problem, I would like to review using law of cosine as well. So I'm looking for side C in my picture. So I'm going to use this version of law of cosine because it has C squared. It's kind of got C isolated. In order to isolate it, we have to take the square root of both sides. So a square root of a squared plus b squared minus 2ab cosine of capital C. So let's go ahead and do this and see what we get. So we're just going to substitute in A, B, and C from our picture. Okay, we're just going to substitute A, B, and capital C. Be careful, it's we haven't found capital C yet, but how can we find capital C? Can you tell me that? You guys should be able to answer that question. How do I find capital C, considering I know A now? I know angle A. Let me put it in the picture. So angle A is 125.1 degrees. Now that I know angle A, how can I find angle C without having to use law of sine, law of cosine? Because I need angle C in order to use this. How can I find angle C? Very good. Very good. That's right. So let's just subtract angle 180 minus what I got, 125.1 minus, I believe the other angle is 39 degrees. Okay, so angle C, which it isn't really asking me for angle C, I need it, is 15.9 degrees. Okay, so let's see. Let's see if we can do this now. Square root of, okay, a lowercase a is 26 plus b is 20 minus 2 times 26 times 20 times the cosine of my angle, capital C, 15.9 degrees. Okay, so I'm going to type that into my calculator. Kind of running out of room here, so I'm going to have to shift over. Let's see, square root of 26 squared plus 20 squared minus 2 times 26 times 20 times the cosine of 15.9. And by the way, if you guys see me make a mistake, please let me know. Okay, so I get 8.71. Okay, 8.71. Okay, so let me just check this really quick in the problem. So 125.1 degrees and 8.71. Let's see if those are correct. Okay, and in fact, they are correct. Okay, so the point of the problem is you've just got to watch out for these, these other angles that can sometimes be your correct angle. Okay, all right, very good. So again, your picture may not be drawn to scale, but the picture should be in the neighborhood. It should be roughly correct. It's not going to show you an obtuse triangle and then the solution being an all acute triangle. We're not going to do that to you. Your picture should be roughly correct. Okay, good. Now, since we spent the first 30 minutes going over that question, we're going to have to move on, unfortunately. Otherwise, we risk falling behind. You're welcome. No problem. So it was a good question to review because it helps us with what we talked about last time. So it's not a waste of time. We just don't want to fall too far behind. So it's a good question. And you'll probably see something like this on your midterm exam. Now that we have everybody here, or at least I think we've got everybody here. Okay, let's talk about what I had on the whiteboard at the beginning. Okay, so today our objective is to finish trigonometry. We're going to finish trigonometry. We're going to do we're going to do probably one more example of what we talked about at the end of class last time. I'm going to show you two examples. One that is similar to what we did at the end of the period last time. And then we're going to do one more example where I show you a very convenient shortcut. And you can choose whether you want to use the shortcut or not, of course. The other thing we have to do after after we finish doing what we were talking about at the end of period last time, we've got a little bit more trigonometry to do. We're going to talk about a couple of trig identities that we haven't talked about yet, and so more trig identities. So we talked about trig identities at the beginning of the period last week. We're going to talk about those again, just some different trig identities, and then we'll probably take a break at that point. And I don't know. I don't know whether we'll take the break before or after we start those other trig identities. But sometime after we finish all that trigonometry, we will start talking about systems of equations. And that is the second major portion of the course. Please be aware that what we finish today and at least part of what we talk about next week, will be on your midterm exam. Now that leads us into your midterm exam. I want you to note that in red here, I have midterm exam is in 2 weeks. It is an in-person exam. It is not online. It is at the North Humber campus, and we will start at 9 a.m., not 8 a.m. It will be at 9 a.m., not 8 a.m. I know our class normally starts at 8 a.m. Okay, so our exam will start at 9 a.m. So if you want to get there at 8 a.m., that's fine, but I don't think anybody will be there except for yourself, maybe, until 9 a.m. It would be a good idea to get there a little bit early, maybe 8:50 or 8:55 a.m. The room number on the North Campus is E338, and I want to confirm that in my schedule because occasionally they will change the classrooms. Okay, it's still E338. They haven't changed it, so that means it will probably continue to be E338. So I don't anticipate that if it's not changed so far, it's probably not going to change. So very important, midterm exam in 2 weeks on the North Humber campus. We will start at 9 a.m. and you will get you guys get the same amount of time as all other Tech Math 204 students. You get 1 hour. It's roughly an hour and a half. I sometimes give students a few more minutes. You know, I'll give you probably from 9 a.m. until probably somewhere around the end of class, which is the end of class is at 10:40 a.m. Okay, so that's just enough time to go over the exam, allow you to complete the exam. Okay, now we will elaborate more on the exam next week. Okay, we will elaborate more on the exam next week, but if you do have any quick questions related to exam logistics, you're welcome to ask. You can expect a fair number of problems, and when I say fair, I mean a reasonable number of problems. I write your exam. I'm the test author, so I wrote your exam, and it is in a complete state. As far as I know, you're looking at probably something like 10, 11, 12 questions. 10 to 11, 12 questions. And I say 10, 11, 12 because some of the questions will have parts, like a part A, a part B, a part C. So, when you resolve all, sort of collapse all those parts, it ends up being something like 10, 11, 12 problems. And of course, they will come from what we've talked about so far. Also could be problems that we talk about today, and some of what we talk about next week will be on the midterm exam. Okay, so very, very important. Are there any questions about the exam? Again, we're going to answer questions about the exam next week as well, but in case you have any questions right now, I certainly would like to address those concerns. If you have no questions, we will go ahead and get started today with our topic. We'll take our break probably sometime around 9:10, so 10 after 9, so 9:10 a.m. Today. So that's about in about 30 minutes. I don't know, 9:10 or 9:15. So sometime around 30 minutes from now, we'll take our break. Okay, let's see if we have any questions. Okay. All right. I do not see any further questions. All right. So let's go ahead and get started then. What we were doing last time, if you go back, if you, I don't know if you've gone back to look over the recording video. And by the way, you guys do know that your lectures are recorded and posted in the ideas, right? Hopefully you know that. So you can go back and it's, by the way, it's always a good idea at the, a few minutes before class starts. It's always a good idea, in my opinion, to go back and look in the online lectures and recordings folder and just watch the last few minutes of the lecture from last week just to see what we were doing. I actually do that even though I'm the instructor, because I teach 4 sections of Tech Math 204, so they don't always stay on the same timeline. So I like to go back and watch just the last 5-10 minutes of the lecture, and you can do that by just clicking this link right here. Last week's lecture is lecture 4. This is lecture 5, and you can watch it. I post them to YouTube. Please be aware the videos I post on YouTube are unlisted, so you can only get access to them if you have that link. Okay, so it's really just you guys. All right, so anyway, what we were talking about last time was this business of this CAST system. This, I call it the add sugar to coffee system, to find all the solutions to a trig equation that are less than 360 degrees. So we're going to continue to talk about that today. And in particular, what we were talking about last time was the case where there is a square, an exponent of 2. And it turns out that what we're using here applies for any exponent, exponent 3, 4, 5, 6, 7, any exponent. Now, it turns out that one issue is you end up with these, you can end up with these complex, you can end up with these, I don't want to call them complex. You can end up with these weird solutions if you get higher powers of x. Higher powers of exponents. So we don't worry about that. And for you guys, the squared case where the exponent is 2 is the most important and really the only thing you will consider in your technology courses. So again, the way we start these problems is we have to first isolate the trig function. And another thing I'm going to say here is you should probably rewrite this a little bit differently so that you understand what the problem means. Cosine squared means to take the cosine of x and multiply it times itself. So cosine of x times cosine of x. Now, what we have to do here is isolate this squared trig function. So you're just going to use standard trigonometry to do that. Sorry, standard algebra, not standard trigonometry. And by the way, I made a little mistake. I apologize. I made a little mistake here. Can we please fix this? I'm going to change this -2 to -1. I made a mistake. Okay, so change that -2 to -1 right there. Okay, now when we do that, that changes this -2 to -1, and then this will be -2, right? So I made a little mistake when I wrote the problem down. So, all right. So, All right, so to continue to isolate, I'm going to divide both sides by -3. And of course, -2 divided by -3 is the same as 2/3. Now, here's where things are a bit different from those problems we were talking about. Well, it came up in this problem over here that Brian asked about, but the thing that was different is this square, and so we have to isolate the trig function. So we have to take the square roots of both sides, and when you take the square root of both sides, you end up with this plus or minus effect. And we talked about that last class. You'll need to go back and watch the recording to see what that's all about. But you must put that plus or minus over there, or you won't get all the solutions. It turns out there's going to be 4 angles, x, that satisfy this. And the reason why there are 4 angles is because there's actually two equations here. There's positive square root of 2/3. And then there's the other one, the minus cosine of x is minus square root of 2/3. So there's really 2 equations here. And as the result of there being 2 equations is we have to solve the 2 equations, and each equation has 2 solutions. So 2 times 2 is 4, right? So what we do now is we continue just like we did last time by finding the angle with the calculator using the inverse trig functions. We just use inverse cosine. We just use inverse cosine. All right, so let's use inverse cosine to find these 2 angles. Now, this is 2 of the 4. There's going to be 4 solutions. Okay, so solution number 1 is 35.3 degrees. It's positive, so I don't have to do anything special to it. The problem is asking for all positive angles or all positive solutions less than 360 degrees. So, so far we're doing good. Now, the other solution comes by putting a negative sign in front of this square root of 2/3. So I'm just going to go back and put a negative sign. Make sure you put a negative sign and not a minus sign. Some calculators do not like a minus sign. You got to put a negative sign, or the calculator may error out. So the other solution, one of the other solutions is 144.7 degrees. Okay, so we have 2 solutions. However, we know that there may be another solution for each of these equations because of add sugar to coffee or the caste system. Okay, so what we have to do is we have to look at our picture for each of these. We're only going to look at one at a time. Add sugar to coffee. Add sugar to coffee. Okay, so let's take a look at this equation over here. So I want to be clear. This says cosine is positive because the square root of 2/3 is a positive number. You can check it. It's like 0.816. So this right here says cosine is positive. Okay, so we kind of already knew that because we got an angle in the first quadrant. And in the first quadrant, all trig functions are positive. So we got 35.3 degrees. We now need to figure out which other quadrant cosine is positive in. You know, because of this system, that C right there means cosine is positive down here. So what I want to do is draw a mirror image down into the 4th quadrant. Okay, so the other solution, the other angle is the angle in standard position that goes around counterclockwise. Counterclockwise. So that will be 360 minus 35.3 degrees. Okay, so let's type that in and see if we can get an angle here. All right, so 324.9 degrees. So that is another solution. So we've got three solutions now that are less than 360 degrees, but positive. So we need to do exactly the same thing over here on the right for our other portion of the equation. Now, this says the cosine is negative. You can see because it's got a negative sign, right? So cosine is negative. Let's write that down. So cosine is negative. So, and we already know one of the angles where cosine is negative is 144.7. Now that is less than 180, but greater than 90. So it's going to be somewhere, I don't know, somewhere like that. Let me draw it in a different color. It's going to look something like that. Right. 144.7 degrees. So just like the last problem, except in the last problem, cosine, our last portion of the problem, cosine was positive. Now cosine is negative. So I need to figure out where else cosine is negative besides the second quadrant. Remember, cast or add sugar to coffee tells you where cosine is positive. All are positive in the first quadrant, so it's not there. And cosine is positive in the fourth quadrant, so it's not there. That leaves only down here in the third quadrant. That's the only option. So what I need to do is to draw the same angle the other way going clockwise. So I'll use blue. I'll draw the same angle going around clockwise. That's not very good. So that will be 144.7 degrees that way. And again, if you want the actual solution, you have to go around as an angle in standard position. That means we want to go around, we want to go counterclockwise around to the angle. And that will be 360 degrees minus 144.7. Okay, so let's write that out, 215.3 degrees. Now, it turns out that you can check your answers with these. Yes, you can. You can check your answers, and you should check your answers because you don't want to do all this work and it be wrong. So we got our four angles there, 35.3 degrees, 144.7, 324.9, and 215.3. So how do I check my answer? Well, there's several ways to check your answer. The best way to check your answer is to go back to the original first equation. Where is that? Okay, it's way up here at the top. Let me get my whiteboard. It doesn't like to be laid down and written on, apparently. All right, so here is my original equation. So what I can do to check these is to just use the left-hand side of it and just type in the left-hand side and replace X with each of these angles. And you have to be careful because you can't type in cosine squared. You have to type it in with brackets. So it'll be 1 minus 3 times bracket cosine of my angle. So my first angle is 35.3. Close the bracket for the cosine and close the bracket for the square, and then you should get -1. And we got pretty close to -1. The reason why it's not exactly -1 is because there is a little bit of rounding error here. And there will almost always be a little bit of rounding error. So it's pretty close to -1. To check the other three solutions, just go back and change your angle to one of the other angles, 144.7. We should again get -1. And we do. -0.99 is pretty close to -1. The next one is 324.9. Again, we should get -1. Got -1. We got a different, close to -1, but closer from the other side. It's interesting. And then 215.3 is the other solution. Oh, shoot. I typed in 216. Let me do that again. 215. And you get -1. Okay, so we know that these solutions are correct now. So we talked about an example of this last class at the end of the period. So here is another example. What I'm going to be doing next is I'm going to show you how there's a shortcut for doing these trig equations that have cosine squared or sine squared or secant squared or cosecant squared or cotangent squared or tangent squared. There's a trick to doing them, and I'm going to show you that next. However, before I show you that, are there any questions about this problem? Very, very important problem. Any questions? Okay, no questions. Very good. All right, so I want to show you the trick to this. There's a trick, and this trick is really nice. And some of you might already see it. And this trick, you can use it on your midterm exam. I do not expect students to do all of this work if you're not comfortable with it. You're welcome to use the shortcut. You know, you guys are intending to be engineers and technologists and people that work with technology. You're not training to be mathematicians. So I don't expect you to use very long methods, especially when there's a shortcut available. Okay, so the shortcut is this. The shortcut is you have to do basically everything down to, let me show you, you have to do everything down to, let's see, so if I'm following my work, I will highlight in bright purple here so you can see it. So you have to do everything, everything down through here. And you also have to find this first angle. You do not have to do any of these other cases, it turns out. Again, this trick only works if there is a squared trig function. And you're very likely going to see one on your midterm exam. Okay, so you have to work down to at least right here. Okay, so let me clear this up so it's not a mess now. So we have to work down to here. And let me just show you how you can get those other angles very quickly. Okay, here's how it works. Draw this angle. Except when you draw it, make sure you draw it all the way through the origin. Okay, so 35 degrees, I'll draw it in blue. 35 degrees looks, I don't know, something like this, right? Except don't stop drawing. Draw it straight through the origin, straight line. That means this angle's 35.3 degrees, and this angle's 35.3 degrees. And then draw exactly the same reference angle in the second and fourth quadrant. So draw exactly the same reference angle in the second and fourth quadrants. All these angles are exactly the same. And if you now measure those or calculate them as angles in standard position, you now have all of your solutions. And this works every single time. So that angle, 35.3 degrees, is the first one we got. That angle is 180 minus 35.3. That was the second angle. The next one, 180 plus 35.3 degrees. That's 215.3. And finally, 360 minus 35.3 is 324.9. This trick works every time when you have a squared trig function, and it's very, very convenient. Very, very convenient. Okay. Are there any questions? On the exam, you are welcome to do these problems using this trick, or you can use the long method if you prefer. It's up to you. It would be nice to save yourself some time, though, right? Any questions? Let's see if we could fish up a problem on ideas. I don't think we're ready to do a live poll, so don't worry about live polls just yet. Let me look at chapter 18 practice. Okay. Oh, by the way, I have to get rid of this question. So if you are working through chapter 18, I need to get rid of a question because it's way outside the scope of the course. So let me get rid of this question. So question number 9 is going to be withdrawn. If you have already started it, then don't freak out. It only grades you out of what you're allowed to do. Okay, so let me go back again. So I want to look. Well, that's funny. I don't see any good ones in there. I'm surprised. Okay. Oh, I've got an idea. Let's go to the midterm exam review. I haven't talked about the midterm exam review, so I'm going to go to it now. This is as good a time as any. Okay. So what are we? D6A, I think so. So it turns out there is a review document in the midterm exam folder on ideas. So if you scroll down to the midterm exam folder, it's kind of like a pink color. And inside there is a midterm exam review and a formula sheet. There's several reviews. Let's look at this PDF exam review. And let's see what we could see here. I want to go over a question from this. So let's see. I see one I want to do right there. Solve the following system. It's not a system. I'm not sure why so this was written by my colleague. I think she has a typo here. It's not a system of equations. For all non-negative values of 0, theta less than 360 degrees. Okay, so we want to find the angle. Oh, good Lord, that's huge. Okay, so we just want to, and please ignore that C. That C is just the label. Okay, so we want to solve this equation. Now, we talked about this, I believe, last time. If you have a something other than sine, cosine, or tangent, you have to use your trig identities from your formula sheet, right? You have to use your trig identities from your formula sheet. So where are the trig identities that help us here? Well, how can I zoom in on that? Okay, so here are your trig identities. And we've talked about some of these. We have not talked about them all. So cosecant is 1 over sine. So I can replace cosecant with 1 over sine. And, you know, you don't have to take that square out like I did. So let me just put it back in. The trick at this stage is you can do it one of two ways. You can multiply both sides by sine squared of theta, or you can just flip both sides. You can just flip both sides. It's up to you. And then you go through the same process we went through in the previous problem. In fact, the previous problem is probably a little bit more complicated. You have to solve the equation so that sine squared of theta is by itself. It is. And then you take the square root of both sides. When you take the square root of both sides, you have this plus or minus that appears. And of course, what you want to do is you want to solve all these equations. Well, there's only two. Now, remember what I told you, you can use the shortcut. So the shortcut only requires you to find the solution right here. Okay, so let's use the inverse sine to find that solution. Okay, inverse sine, negative square root of 1 divided by 4, close. And let's see what we get. All right, so now it gave us negative 30 degrees. So that is my reference angle. Now, you cannot have, you know, this is a great reference angle, negative 30 degrees, but you got to have a solution that is positive. So you can't use negative 30. So the way we get a positive counterpart angle that is a solution is we just add 360. But you should still remember that that negative 30 degrees is going to be our reference angle. So I'm going to add 360 degrees to this to get a positive angle. Okay, but this negative 30 degrees is our picture, is useful for our picture. So what we're going to do now is instead of doing all this other work, I'm just going to use the shortcut. And I'm just going to use this 30 degree, negative 30 degrees reference angle. And I'm going to draw 30 degrees all the way through the origin. And then I'm going to do the same thing in the other direction. I'm going to draw a 30 degree reference angle. I've got a protractor on my screen. You guys can't see it, but it helps me draw angles and straight lines really well. Pretty useful. And so these are your 4 solutions. That angle, which is 30 degrees. That's 30 degrees because the reference angle is 30 degrees. So that's one of my solutions. That will be 180 minus 30. $150. The next solution will be 180. Oh, sorry. 180 plus 30. 180 plus 30. 210. And you already know the last one, but we'll calculate it anyway. It will be 360 minus 30. We've already figured that out, though. 330 degrees. So those are your 4 solutions. Okay. All right, so you're welcome to use that trick. It saves you a lot of time. It will only work if you have this squared trig function, though. Okay, if there's no square there, then you have to use what we talked about last time and in the in the example that Brian asked about earlier. Okay. So that brings us to the end of solving trig equations. That brings us to the end of solving trig equations. Are there any questions? Okay. See if we have any questions. Okay, does not look like it. Okay, so what we're going to do now is we're going to take a break. We're going to take a break. I hope that's okay. Take a break. And we're going to take about 10 minutes. And by the way, I might need a few more minutes during the break. So I'm going to add a couple of minutes to the break. And we're going to make this a 12-minute break. And I will try to get back as soon. I have to run downstairs and pick something up, a perishable item. And my girlfriend, Andrea, is freaking out about it. So I have to go down, and sometimes it takes a little bit of time to manage these things. So we're going to take a break of 12 minutes. And if I'm not right back at 12 minutes, I will certainly be back very soon after 12 minutes. All right. So go ahead and take your break, and we will see you in 12 minutes. Okay, welcome back. All right, are there any questions before we get going again? Any questions about anything before we get going again? I do want to say, just in case someone came in late, I want to say once again, or maybe someone was away from their keyboard or something. I want to say once again that your exam is in 2 weeks. It's not online. It's at the North Humber campus, and we will start your exam at 9, not 8 o'clock, but 9 o'clock a.m. So not at 8 o'clock. We'll start at 9 o'clock a.m. and it will be in room E, as in Edward, room 338. 338. That's at the North Humber campus. Just another reminder. That's in 2 weeks. 2 weeks from today. Okay. I don't see any questions. Let me just confirm here. Okay. So the final topic before we start part 2 of the course is we're just going to do a little bit of work with a couple of other trig identities that sometimes come up in your applications. Okay. Now, these identities, they don't come up often, but you just need to know how to use them. Okay, you just need to know how to use them, and using them is pretty easy, especially if you have your calculator. And we just want to go through a few examples of how to use these identities. So the full set of identities is listed on the formula sheet, and here they are for your formula sheet. So we use capital A and capital B. On my presentation, I'm using alpha and beta. I think on the formula sheet it uses capital A and capital B. Now, you should also be aware that we do not use all of these. In fact, you're only really responsible for the ones with sine and cosine. Now, even though we give you the tangent, you don't need to know it. Well, you don't need to memorize any of them. But there are many other identities. This is just a list of several of them that are oftentimes applicable. The most applicable ones are the ones with sine and cosine in them. Also be aware that there are multiple versions of, this is called the double angle identities for the cosine. And we'll look at an example of something that uses these, well, some combination of these three cosine double angle formulas. And it's a little bit trickier to use because there are 3 options. But anyway, we're just going to go do some examples of how to use these, and that'll bring us to the end of the trigonometry and complex number portion of the course. So what I want to do is I'm going to snip an example problem and put it into my whiteboard. Okay, so it's very simple how to use these. This is an example of a sum of 2 angles. The 2 angles are cosine of well, the two angles are x and 3y. So you're adding these angles. And so it's really just an issue of just directly substituting these into one of these identities over here. So you'll notice the first thing you observe here is that this is the sum of two angles, right? It's the sum of two angles. And so over here in the formulas, this plus minus that you see here and here means that you just keep the sign when you go from the left-hand side to the right-hand side of the identity. So all you do here is you say, okay, well, sine of x plus 3y will be, according to the identity over there, the top one, that is, in this case, it's going to be, let's start, it's sine of A is x, cosine of 3y plus cosine of x times the sine of 3y. And at least in this case, that's all that can be done. Okay? In this case, that's all that can be done. We don't know enough about x and y to go any further. So that's how you expand using the sum angle identity. So it's a very simple example. There's not much to do. So that's how you use the formulas. So let's go to another example. Just direct substitution. Now it gets a little bit more interesting when you have, well, an actual angle. Gets a little bit more interesting when you actually have an angle. Okay, because now we have to use the, this is a cosine, difference of cosine angles, difference of angles, I should say. And this time we're going to use the cosine formula. Okay, now what this, it's got a plus or a minus here and a minus plus here. That means that if you've got a plus on the left portion, it changes to a minus on the right. If you have a minus on the left portion, it changes to a plus on the right. So the fact that we have a minus in our problem tells us that we are going to have to switch signs on the right-hand side. So let's see if we can do this. So it's cosine of A. So in this case, 45 degrees is A. Cosine of B, which is just X. And then we have to change the sign, so it'll be plus instead of minus. And then sine of 45 degrees, cosine of X. No, sorry, sine of X. Okay, so then what you do is you get your calculator out and you just figure out what cosine of 45 degrees and sine of 45 degrees is. So cosine 45 degrees is, and by the way, if you have a calculator that will write these in exact form, you can leave them in exact form. For example, if you're using the ES Plus calculator, I think the mode and in computation, no. And if you go to you go into computation mode, so press 1 if you weren't already in there, and then you go to setup and you type math.io into that, it will actually give you an option for, this is optional. You can just type math.o, and what it'll do is it'll type your answer exact, I think. Let's see if it does that. Yeah. So you can use the square root of 2 over 2. And if you don't like the square root of 2, you can just convert it to a decimal, and you can use the decimal. Please be aware that you should always use at least 3 decimal places if you're not sure. How many decimal places to use. Let's calculate the sine of 45 degrees. Also square root of 2 over 2. And of course, this will be fine. However, I will tell you in the real world, this usually gets factored into square root of 2 over 2 times cosine of x plus sine of x. I would accept any of these answers. I would accept any of these as answers. I'm not particularly picky about it. You can factor if you want. If you don't want to factor, you don't have to. Okay, let's look at another one. Okay, the next one's particularly interesting. So this is another cosine. It uses the same formula. It says to prove that the cosine of 180 degrees minus theta is actually negative cosine of theta. This is a very simple proof. All you have to do is use the same trig identity that we just used. Okay, so I'm going to use that same trig identity. Okay, so cosine of 1, I'll write it out just to make it look nice. Okay, so according to the identity, it should be cosine 180 degrees times the cosine of theta minus, I'm sorry, plus, because the sign switches, and then sine of a 180 times the sine of theta. And of course, you can get your calculator out. Some of you probably know that the cosine of 180 degrees, let's see, cosine of 180 degrees, I believe, is -1. Let's check it. Cosine 180 degrees, -1. And then sine of 180 degrees is 0, I believe. Yeah. So you can see that this 0 here causes that whole right-hand side to just disappear, and all I'm left with is negative cosine, and that's my proof. So I was trying to get to cosine, negative cosine of theta, and I did. So pretty interesting example. So this is how you use these trig identities. Again, it's pretty straightforward. Any questions? I'm gonna grab another problem and check and see if you have, and then check to see if you have any questions. We're not going to do the proof because the proof is probably outside the scope of the course. Okay, any questions so far? Okay, I don't see anybody typing. I don't see any questions, so I guess we're good. So the next question is a little bit more practical. Let me bring this down here so we can see it. All right, so it says to simplify this weird trig expression. And notice you have double angle, trig functions with double angles in them. Like you've got sine of 2x and cosine of 2x. So we can use some combination of these trig identities over here to help us simplify this. So for example, you can replace a over here with x, and you have, you have a way to use these. So it says here, this identity right here says that sine of 2a is 2 times sine of a times the cosine of a. So let's use that on the top. So 2 times sine of x times the cosine of x. So that's the top, the numerator. Now, what you kind of want to do with the denominator here, this is where you've got cosine of 2x. What you would kind of like to do is maybe use, use one that seems appropriate, because there's 3 different versions of cosine of 2a. And something that I see that I like is I like the second one, because I see 1 plus, and then in this thing I also see 1 minus 2. So the second cosine of 2a will work, but another good option is the third one. The third one's a good option because I have plus 1, and then I'm going to have minus 1. The plus 1s and minus 1s will cancel. So I'm actually going to use the third one. But it turns out that you can use any of them. It's just some are sometimes a little easier than others. You can still use the first one, but with the first one, you have to do a bit of rearranging. So let's use the third one. Let's see. It says that cosine of 2a, or in this case 2x, is 2 times cosine squared of x minus 1. So I've replaced cosine of 2x with 2 times cosine squared of x minus 1. Now, of course, you don't have to put those brackets around it. I was just doing that to show you what I was substituting. But when you remove those brackets, which of course you can do because of the associative law, you can just cancel those 1s. And of course, that now allows you to cancel out cancel out the 2s. And also, remember, cosine squared means cosine x times cosine x. And of course, we can now cancel out a cosine, and that leaves us with sine of x over cosine of x. I don't know if you remember what sine of x over cosine of x is. Well, it's back on your formula sheet. Right here, sine of x over cosine of x is tangent of x. So that simplified very nicely. So that is another example of using double angle or sum and difference of angle identities. There's not a lot of application for these, but they come up in very irregular places. You know, they show up in sort of unexpected places. All of these problems do, or these types of problems. So all you really have to be able to do is use them. We ask you to do a few problems that are similar to what you've seen here today, and there are 4 examples, and that's basically it. So you need to be able to use those identities. Once again, you do not need to worry about the tangent, the sum of angles for tangent. You don't need to worry about this one. It doesn't show up, but it's really not that difficult to use. It's the same process. Okay. All right, so now is a good transition point. Are there any questions? So I'm going to stop for a moment. We're not going to take a break, but I'm going to stop for a moment because what we now have done is we have completed the first part of Tech Math 104. So there's really three parts, three big global parts to Tech Math 204. And the first part we've now completed. The first part I like to call the complex number trigonometry portion. And, you know, we didn't talk about complex numbers much here in the last week or today, but it is all related because of Euler's formula, which we talked about way back like 3 weeks ago. This brings us to the end and concludes the complex number and trigonometry portion of the course. Any questions? So at this stage of the game on ideas, let's go to ideas. You should be able to complete all of the practice assignments, chapter 21, chapter 15, chapter 17, and chapter 18. The only thing you might not be able to complete at this stage is chapter 10. So if you haven't started to work on the practice assignments, you need to get started on it because we're running out of time, right? You've only got 2 weeks left to work on them. But at this stage of the game, you should be able to do all these assignments except for maybe chapter 10. And of course, next we're going to start talking about chapter 10. All right. Okay, any questions at all? Okay, I don't see any questions, so we're going to start part 2 of Tech Math 104. Okay. Okay, so part 2 is some basic linear algebra. So I want to give you sort of the context for what the purpose of part 2 of Tech Math 204 is. The purpose of part 2 is really around circuit analysis for you guys. Now, we do not do much circuit analysis in here. I'm here to teach you the math. I'm here to teach you the math. So I do want to motivate it. So so I want to motivate it before I actually we go into some examples. So the motivation for talking about this is in your Tech 101 course, you probably did some circuit problems where you were doing things like this. You have a circuit with, I don't know, there's a simple circuit. So maybe there's a resistor, you've got a voltage source of some kind. Maybe you got a couple of resistors, I don't know. And then you have another portion over here, which will have another voltage source. And maybe there's another resistor in here. Please forgive my not so great circuit diagrams. Okay, so in those core, in Tech 101, you would have talked about finding the current or some other characteristic through these different pieces or different loops. I'll call them loops. you're sort of trying to figure out what I1 and I2 are. You're trying to figure out the current through each of these pieces of the circuit. And of course, you may be given information about the resistors. You might be given the resistance here. I don't know. For example, this might be a 300 ohm resistor. This one might be a 280 ohm resistor. This one might be, I don't know, 360 ohm. I don't know. I'm just making up some values here. And so what you would do is you would use a combination of Ohm's law and something called Kirchhoff's law. Okay, I don't know how to spell his name, honestly. I'm tempted to just do it the simple way, but you had this guy named Kirchhoff, and he had all these electrical principles, and I think it's his second law, Kirchhoff's second law, says that as you're going through a closed loop, the voltage has to go to zero. And there's a couple of ways to say that. Some people say the voltage going in has to equal the voltage going out. Yeah, there's a couple of ways to say. Anyway, this involves finding I1 and I2. So what you end up with is some kind of an equation. You get two equations. You get one equation for this portion over here. For this, you get one equation for this portion here, and then you get another equation for the other portion. That's two equations and two unknowns. All right, two equations, two unknowns. And so you've seen this many times before, probably. It results in something called a system of equations. Sometimes your professors in technology will call it simultaneous equations. I don't like to use that word because simultaneous implies that time is involved. Certainly time is involved for you guys, but in the general case, time is not necessarily involved. So I call these systems of equations. Okay, so the process and all the methods and all of the tricks and shortcuts associated with solving systems of equations is taken care of in the field called linear algebra. So we do some basic linear algebra. Okay, so the point is that you get two equations and two unknowns, and you want to be able to solve them. Now, we'll eventually get to three equations and three unknowns. And when you get to three equations and three unknowns, you will, you'll be able to do it on 10 equations and 10 unknowns, or 50 equations and 50 unknowns. Now, let me be clear. You would not be dealing with anything larger in this course than three equations and three unknowns, because it takes so long to do anything larger than that. Three equations and three unknowns is manageable, but four equations and four unknowns takes a long time, and it just gets longer and longer. So what we're going to do is we're going to look at an example. Okay, so let's look at a system of equations. So usually when you see a system of equations, you want to solve for the two variables. Okay, so let's say we have 2x plus y is equal to 1, and x minus 3y is equal to 2. So this is a simple equation. Now, in the circuit example, it will be I1 will be your x, and I2 will be like your y. And the resistance corresponds to a fairly large number, 300, 280, or 3. Here, we want to start with simple values like 2, 1, -3, things like that. You know, we want to start with, we're not going to use large coefficients or resistances. At least that's the context you guys think of it in. So we need to start with simple examples. And so these problems are, these are examples of solving systems of equations. This is the prime simple example of a system of equations. Okay, so what the idea is, you want to solve it. And solving means to find x and y. Now, more interestingly and more probably a bit more useful is there's another way to interpret these. You can graph both of these lines. You guys know how to do that from Tech Math 104. You can use slope-intercept form. I'm going to use Wolfram alpha. Let me disable my sharing here for just a moment. Bear with me. You can use like software pro. I mean, you don't want to use these. You can't use them on a test, but a website like Wolfram Alpha will help you to get a picture of, you know, what it is you're trying to do. It's a good learning tool. Okay, let me go back to sharing. All right, so I've got Wolfram Alpha up here, and let's split my screen. Let's put the problem on the left and Wolfram Alpha on the right. So Wolfram Alpha, you can just type the two equations in. And of course, Wolfram Alpha will tell you the answer, but I'm not really interested in the answer here. The solution. So the solution is x equal 5/7 and y equal -3/7. What is more interesting here is I have a picture of the two lines. Right, I've got a picture of the two lines. And you can see, well, I don't know if you can see really well. But these correspond to the values of the solution. So what you're really doing when you're solving the systems is you're trying to find the intersection point of two lines or two relations of some sort. Okay, so there's several methods for solving systems, and that's what part 2 of the course is about, really. Part 2 of the course is about methods for solving systems of equations. So we talk about the first method today, and we're going to talk about the first method next week as well. So the first method and the simplest method is called the substitution method. Now, the substitution method is really useful in the sense that it is universally useful. You can use it just about anywhere. You can use it just about anywhere in any circumstances. The other methods that I will teach you do not always work. They work most of the time, but not all the time. Okay, so the idea with substitution is step 1, solve one of the equations for one of the unknowns. You guys probably already know this. And then step 2 is substitute into the other equation. Oh, sorry. Substitute into the other equation. So if I want to do this problem, I want to be kind of careful about which variables I choose to isolate or solve for. So my step 1, I should choose a variable that is convenient. Okay, for example, either x in the first equation or, sorry, y in the first equation or x in the second equation work well. Because let's say I choose y in the, actually, let's choose x in the second equation. So if I solve for x in the second equation, it's a one-step process. And the same is true if I solve for y in the first equation. It's a one-step process. But I want you to notice that if I say to choose solve for x in the first equation, let's just write it down. It's a more than one step. And so you want to strategically choose which variable and in which equation you want to solve for. So if I want to solve for x in the first equation, I have to first subtract y, but then I have to do another step, divide by 2. And also, that leaves me with this rather inconvenient fraction. Fractions we'd rather not have them. Okay, we'd rather not have them. So my point is be strategic. There's nothing wrong with this. It'll work. This will work, but it's not particularly helpful. I would say use this instead. So isolate a variable that is easy to isolate. Okay, I would not do this, but it's not wrong. Okay, so then all I have to do is substitute, it's part 2, substitute this into my other equation. Okay, let me move my steps down. And so I'm going to substitute into my other equation. All right, so my other equation is 2x plus y equal 1. So I'm going to replace x in the first equation with 2 plus 3y. And that will allow me to solve for y because there is no longer any x in the equation. So you guys should be proficient at solving linear equations. So I'm not going to talk about solving the equation from this point. You guys should be experts at this. So I'm just going to go through it very quickly. 4 plus 7y is equal to 1. Subtract 4 from both sides. And then divide both sides by 7. So I get y is negative 3 over 7. And of course, if you look at Wolfram alpha, that was the same y value. That was the same y value that it lists as a solution. Now, finally, you have to find the other variable. So you have to find x. So you want to find a convenient place to substitute y in, probably in some of your previous work. Okay, so we'll go over here, and we're going to substitute y in to this equation. Now, I know some of you are very tempted to convert everything to decimals. I will tell you that if you do it with fractions now and you get started dealing with fractions, this will become considerably easier in the long term in terms of fractions. If you write everything in decimals, it's just going to get harder and harder and harder. It starts out easier with decimals, but then when we start talking about matrices and elimination method, decimals are horrible. So I want to encourage you to please get used to using fractions here. And so I'm going to use fractions here and get a common denominator. Let's say 3 times 3 is negative 9 over 7. And I can get a common denominator here by multiplying the top and bottom of 2 by 7. So that gives me 14 over 7 minus 9 over 7. And you can just subtract the numerators. 14 minus 9 is 5. So 5 over 7 is x. So you can see in Wolfram alpha that that's exactly the same solution that it came up with. That's the intersection point of the two lines. Now, I expect that you guys have seen this method many, many times before. So we're going to do a live poll question now. So this is live poll 5. Oh, hold on a minute. Got to go back to instructor mode. Okay. I'm going to give you guys 5 minutes to get started on this problem. And then we're going to work it together. Okay. Now, if you can't get the whole problem done in 5 minutes, don't freak out. We're going to work it together, and I'll show you how to make this problem not too bad. By the way, the second equation, you can divide out the 16s, which will make this a lot easier. So in the second equation, you can divide out the 16s, and it will make things a lot nicer. Okay, so I'm going to give you guys 5 minutes to start this problem. If you aren't comfortable yet, don't worry about it. We're gonna keep working. So this is the next problem we're going to work. I think this will probably be the last problem we work because I'm starting to get ahead of schedule, and then we'll continue this next week. So I want to do this problem, and I'll try to get this into. Let's put it up here so you can see all the work from the last problem. Okay, so I'm going to give you guys 5 minutes. Good luck, and then when we're done, when 5 minutes is expired, we'll work it together. I'm going to turn my camera off while you're working. Okay. All right, so let's do this problem. Then we'll call it a day. I think we're finished a little bit early today. We're going to do more of these systems of equations next week, so just don't want to get too far ahead of schedule. All right, let's see if anybody has answers yet. It's okay if you don't. I do have one result. Okay, so the first thing I would do looking at this is I noticed that there's a 16 or a negative 16 in the second equation. So I can rewrite my system and just copy down the first equation, right? And then the second equation, I can divide through it by 16 or negative 16, whatever you prefer. And that gives me a nice, much more simplified equation, right? If you use negative 16, it'll look even better because that causes the signs to change. So I'm going to use this version of it. Okay, so the substitution method says solve for one of the variables in one of the equations. Find a variable that is easy to solve for, like x right here, or y. I'll solve for y this time. Doesn't really matter which one you do. To solve for y, we would subtract x from both sides. And then the second step is to substitute into the other equation. At this point, this becomes a really trivial problem that everybody in here should be comfortable with solving on their own, or at least this equation. Okay, so 7 times negative 1 is negative 7, and 7 times negative x is negative 7x is equal to negative 19. You want to collect and combine your like terms. Add 7 to both sides. And divide both sides by 3. So I get x is equal to negative 4. Now I also have to find the other solution, the other part of the solution, and that's the y value. So to find the y value, I have to substitute that somewhere convenient, and probably in the work you did before earlier should be a convenient place to substitute it in. So I can substitute it right there. That gives me y is equal to negative 1. Now be careful, minus negative 4. You got to be careful with that. Minus negative 4, so that's negative 1 plus 4, which is 3. So my solution should be as an ordered pair, which is usually the way you write the solution. Solution is, yeah, you probably want to write the solution as an ordered pair. At least I expect that's what ideas wants. Negative 4, 3. Let's see if that's correct. And in fact, it is. Okay, so I'm going to give you a moment there. Please remember, I use live polls as an attendance mechanism. So if you're not in the live poll, it's almost as if you're not here. So you need to be doing the live polls and at least taking part in them. I do not penalize students for getting wrong answers, but I do use it as an attendance mechanism. So you do need to make sure that you're doing the live polls, at least typing in some kind of an answer. Okay, so there you go. Now, that's going to wrap us up for today. We're going to continue talking about the substitution method next class, and that is next Friday. And we're also going to talk about the elimination method, and that will conclude the material for the midterm exam when we finish elimination next week. So I don't want to get us too far ahead of schedule, but that's the idea. Okay. All right. So are there any questions about anything? Any concerns? Any comments? If you haven't entered the answer, here it is. And once you've entered it and press submit, you're free to go. And I will talk to you next Friday, I suppose. So I'll be here for a few minutes in case you have any other questions. Otherwise, have a good weekend. I'll be closing the live poll shortly, so please make sure to enter your answer and submit in the next minute or so. Again, if you've submitted, you're free to go. If you have any questions, you can hang out and ask your questions. Otherwise, have a good day. Okay, looks like everybody that's going to answer has answered. I'm going to close. Everybody got the right answer. Okay. All right, I don't see any questions. If you have any questions, please post your questions soon because I'm going to shut down the webcast shortly. Any questions?